So I want to define a couple of terms for the energy section of this class now. So we can talk about systems again, just like we did when we covered forces, but the objects you want to include in your system are a little bit different now. In order to make use of, for example, the potential energy, you need to include the objects that are causing those forces in your system as well. So for example, if you want to use the potential energy due to gravity, you have to include the Earth in your system because the Earth is what's causing that force of gravity. And there's also other forces that can create a potential energy, like a spring, for example. So if you wanted to use the spring potential energy, you would include the spring in your system. I also want to define mechanical energy, and the mechanical energy is simply the total kinetic and potential energy of a system. So to calculate the total kinetic energy, you just add up the kinetic energy of each individual object. And for the total potential energy, you just add up the sources of potential energy from conservative forces in the system. To define conservative forces, the work done by certain forces is the same no matter what path you take, as long as the initial and final positions are the same, like I showed you with gravity, and those kinds of forces are called conservative forces. These forces can never change the total mechanical energy of a system. That's why they're called conservative. And later we'll see what effect non-conservative forces have.